Okay, so again, I haven't graded this yet, but I'm hoping everyone did well on this question. So I'm not really sure what I need to stress, but I'll just walk through it. Okay, so we told that we're given the parametric equation, and we're given the derivatives. And we're given the position of the particle at t equals 4 was x is 1 and y is 5. And they want us to find the acceleration. Well, the acceleration vector is the derivative of the velocity vector. Okay? And so since they've already given us the velocity vector, the acceleration vector is just going to be the derivative of that. So the acceleration vector is going to be 3 over 2 times the square root of 3t, comma, and then the derivative of this is going to be 2t over 2 times 3 sine t squared over 2. And if we clean that up, we get 3 over 2 square root of 3t, comma, the 2's cancel out, and we get 3t sine t squared over 2. And that's just the acceleration vector. I'll show you the point value for that in a second. I'm not really sure how they scored that. Find the y-coordinate of the particle at time t equals 0, of the position. So if we're trying to find the position at t equals 0, the last time we knew where the particle was at t equals 4. So then we have to say that the initial condition for y, which was 5, plus the integral from 4, because that's the last place we knew where it was, and we're trying to figure out where it is at 3, and then we have to integrate 3 cosine t squared over 2. Now again, don't try to be a hero and do this on your own. You have a handy-dandy calculator. Just use your calculator to integrate this. And I will show you the answers in a minute because I haven't done them, but I'll just set them up. Then C, on the interval, what time does the speed reach 3.5? Well, the speed is equal to the velocity vector, velocity magnitude. And so since we already have the velocity, it would be radical 3t squared plus 3 cosine t squared over 2 squared. And we want to know when is this equal to 3.5. So we, in our handy-dandy calculators, we would, it's bothering me. In our handy-dandy calculators, we would just put this into, and make sure when you do 3, this whole thing is squared. We would put this in our handy-dandy calculators and then just set this equal to 3.5 and then set them equal to each other. Okay? That's the best way of doing that. And again, I'll show you the answers in a minute. And the last one was find the total distance traveled. The total distance traveled is would be the integral of the velocity of the speed. So it's from 0 to 4, the square root of 3t, square root of 3t, quantity squared, plus 3 cosine t squared over 2, that whole quantity squared, and you'd put that in the calculator. Okay? So here are your points on that. The first one was worth 1 point. The second one was worth 3 points. Notice you get a point for the integrand, so make sure you write the integral down. Can't say that enough. And then 1 point for using the initial condition and 1 point for the answer. 1 point for the expression of speed. So again, you had to show that you knew what speed was. So you need to show this expression and then set it equal to 3.5, even though you used your calculator to get the answer. And finally, you get 1 point for the integral and 1 point for the answer. I cannot stress that enough. You have to write the integral down even though you're using your calculator. All right, boys and girls, I hope this was helpful, and I will see you tomorrow. Remember, you have a test tomorrow, so it would behoove you to go over these tonight. I'll see you tomorrow.